All right. What is going on, everybody? I am going to try my hand at Godot again. It's been probably a couple years, but I really want to do some 3D stuff, I guess, but I need to learn Godot better than the way I tried it before. So what we're going to do is fancy. On Godot's website, they have in their documents a setting up the Is that the music? Oh, it's crazy. Okay, they got a not setting up the project, but your first 2D game, and I figured this was probably pretty easy. Is that really the music? That is freaking me out. All right. So I'm gonna do this, and it's just like a little bit at a time. It just tells you what to do. I'm gonna read through it instead of doing like a video tutorial or anything. And I think this will help get me refreshed. And I thought it'd be fun to share with all of you. And I'm also a little bored and need something to do. So that's what we're gonna do. I'm gonna finish my monster so I can stay awake. And this is my first live stream on YouTube. So I've never live streamed on YouTube. I've done Twitch. It's probably been a couple years since the last. Actually, I think it was a year ago. But I've never live streamed game dev before, so this will be fun. Also, there's a lot of things that I need to get used to and get in the habit of if I want to continue to do these live streams every once in a while. Okay. Had to check the stream's audio real quick. Sounds like we're pretty good to go. Okay. So I'm just going to get started here and follow Godot's 2D game tutorial. Goodness, excuse me. Let's start a new project, apparently. The first short person part. Launch Godot, create a new project. And I've already downloaded the assets. So I'm going to go ahead and go to Godot, start a new project. And what is this? Dodge the creeps. Dodge. I'm going to have to adjust this mic here. There we go. Dodge the creeps. And I'm going to put this in my I'm going to put it in my Dropbox. Okay, hold on. Let's just switch to this view while I try to figure this out. Okay, I'm going to create a folder. Am I? Is that what I'm doing? I'm not sure. It's been a minute since I've done some Godot stuff. Some of it is different than it was. It's been through some updates. Why am I having such a hard time? Finding... Oh, there we go. All right. Okay. Let's call this Dodge Game. Sure, why not? And okay, let's go back here. All right. I think I need the assets in that folder, don't I? Dodge game, Dodge Greaves, Dodge games, looks good to me. Yeah, okay. Extract the archive and move art and fonts to the project's directory. Okay, I gotcha. Arts and fonts. Doing this off screen, obviously. Okay. I think I'm good to go. Maybe. We'll see. Okay, it should look like that. Maybe, maybe not. This game is designed for portrait mode, so let's set up project settings. So display, window. Okay, where's project settings? Project settings. Display, window, cool. 480 by 720. Uh-oh. Why is my Steam updating? Oi, what a mess. Okay. Window size 480 by 720. Where did my settings? I exited out of it. Okay. Window width. I already forgot. I'm just gonna put this up over on my second monitor so I can see it. Okay. 480 by 720. Okay, scroll down to the bottom of the section under the stretch options. Oh, yeah. Stretch. And mode to 2D. Fantastic. Aspect. Keep. Shrink 1. Excellent. We will make 3 independent scenes, the player, the mob, and the HUD. And then we will combine that into the game's main scene. So those will just be children of our main scene, I suppose. I'm going to close this. In a larger project, it might be useful to create folders to hold the various various scenes and their scripts, but for this relatively small game, you can save your scenes and scripts in the project's root folder. Okay, fair enough. You can see your project folders in the file system dock in the lower left corner. Gotcha. And there's my, oh, okay, yeah. Oh, there's all my art that I moved over there and the font. Cool. Okay. I'm going to have to figure that out before I stream this again. With the project in place, we're ready to design the player scene in the next lesson. All right. We're through one. Creating the player scene. With the project settings in place, we can start working on the player-controlled character. The first scene will define the player object. One of the benefits of creating a separate player scene is that we can test it separately. Okay? Even before we've created other parts of the game. I think that makes sense. Node structure. To begin, we need to choose a root node for the player object. As a general rule, a scene's root node should reflect the object's desired functionality. Okay. What the object is. Gotcha. Okay. One of the benefits... Oh, I jumped. Okay. Other node button and add an area 2D node to the scene. Other node. And I think I can just type in area. Man, this... Alright. I think that's better. Area 2D. Create. Sweet. Hey, what's going on, Hamed? Welcome in. I'm just relaxing and doing a little Godot. Okay, with Area 2D, we can detect objects that overlap or run into the player. Okay, cool. I guess I can put this back on here for a second. Change the node's name to player, and we've set the scene's root node. We can add additional nodes to give it functionality. Okay, player. Player it is, with a Z. Before we add any children to the player node, we want to make sure we don't accidentally move or resize them by clicking on them. Select the node and click the icon to the right of the lock tooltip. Okie doke. Oh, that one. Gotcha. Lock selected nodes. So now it's unlocked. Make sure the object's children are not selected. Oh, I didn't read. I didn't read it correctly. Great. Keep it up. I will try. I am struggling early on, but we'll keep at this for a while. Appreciate the confidence. Okay, where was I? Before we add we don't accidentally move or resize them by clicking on them. Select the node and click the icon to the right of the lock. Oh, I clicked the lock. Okay, lock. Group. Okay, yeah, it's selected. And then make sure objects children are not selectable. I think I did that correctly. Hamed, have you ever played with Godot? And also, am I saying your name correctly? Make sure. Okay, I think I did that right. I think. Okay, Control S to save. And we're going to keep it in that root folder, is what they said. Yes, I believe so. Player, and I'm just going to save it right there. Excellent. Yes to the name, no to Godot. Okay, cool. Are you Construct 3, or what do you use? Or do you? Sprite animation. All right. Click on the player node and add an animated sprite node as the child. We'll handle the appearance and animations for our player. Notice that there is a warning symbol next to the node. Requires sprite frames resource, which is a list of animations it can display. To create one, find the frames property in the inspector and click empty. New sprite frames. Ew, okay. I tried once, but since Godot is mostly for 2D, I think Construct is better for you. Yeah, it is. Godot is very strong in the 2D development, I've noticed, but I do want to take advantage of some of its 3D stuff. The GDscript looks like it's going to be fairly easy to pick up, but I mean, I'll find out. But I agree, man. Construct 3 is... I love that engine. So I'm still going to stick to Construct 3 for the most part, but I just want to kind of expand. Do a little Godot. I'd really like to do Unity. I tried Unreal. Wow, that is overwhelming. But, yeah. Okay. I am going to click on the player node, add an animated sprite. Add a child node, animated sprite. Sweet. As the child, okay. Requires sprite frames resource in the property of the inspector over here, empty. New sprite frames. Yeah. Click again to open the... Oh, there we go. Okay. Sweet. That is what it looks like. All right, back to it. I apologize. I'm messing with a lot of stuff over here, like I said in the beginning. I'm trying to get the streaming thing kind of organized, and it's a bit of a mess at the moment, but that's okay. Moving on. On the left is a list of animations. Click the default one and rename it to walk. Oh, gotcha. Okay, default. And are they doing... No, okay. They're doing lowercase for the animations. Cool. Then click the new animation button to create a second animation named Up. Find the player images in the File System tab in the Art folder. Drag two images for each animation named Player Gray Up 1 and 2, Player Gray Walk 1 and 2. Okie dokie. let's try that. Another one, it said. And this one was called Up. Right? Yeah, Up. Okay, and go into Art. Player gray up 1 and 2. Oh, nice. Okay. Boy, that was easy enough. Man. The learning curve seems to be pretty good for Godot, from what I can tell. The animations. Okay. Speed. That all looks good. The player images are a bit too large for the game window, so we need to scale them down. Click on the animated sprite node and set scale property to 0.5. Node 2D heading. Okay, animated sprite. Node 2D. Transform and scale to 0.5 and 0.5. Alrighty. Do I need to do that for everything? No. I do not. Doesn't look like it. Finally, add a collision shape 2D as the child of the player. Okay. This will determine the player's hitbox or the bounds of its collision area. For this character, a capsule-shaped 2D node gives the best fit. A capsule in 2D. I guess it makes sense. So next to shape in the inspector, click empty, new capsule. Using the 2 size handles, resize it. Okay. Like it shows there. All right, let's try that out. Player, child node. We need a collision shape 2D. And with that selected, capsule shape. New capsule shape 2D. Capsule shape 2D. Yeah. Okay. Then new capsule. Using the 2 size handles. Okay. Let's zoom in here. Cool. How do you... Is there a width? Transform, scale X, maybe? Oh yeah, you can drag it. All right. Mine does not look like theirs. What's going on here? Huh. Alright. That's fine. Alright. I was just playing around with it. That's what we're going to go with. Okie dokie, moving on again When you're finished, your player scene should look like this. And it does. Make sure to save. And in the next part, we'll add a script to the player node, move and animate it. Then we'll set up collision detection to know when the player got hit by something. And I will Control S to save. And ready to move on. In this lesson, we'll add a player movement animation and set up to detect collisions. To do so, we need to add some functionality that we can get from a built-in node. So kind of like behaviors in Construct. So we'll add a script, click the player node, and click attach script. Ugh, goodness. Okay. Player, attach script. In the script settings window, you can leave the default settings alone and just click create. Okie dokie. There we go. And start by declaring the member variables this object will need. It needs an extends area 2D, which is our class. I'm gonna delete their stuff here. And do that, and that, because I think we're probably gonna need a ready function. I'm gonna start with the export variable, speed equals 400, and variable screen size that has no value. Let's see. Oops. Gotcha. Export var speed equals 400. And then var screen size. Screen size, just how they have it with the underscore. Using the export keyword on the first variable speed allows us to set its value in the inspector. Cool. That means export var means that we'll be able to see and change that variable in the inspector. Great. That's helpful. And that music just, it freaks me out when it does that. All right. I like it other than that. I assume it's on the music. All right. This can be handy for values that you want to be able to adjust, like a node's built-in properties. So click on the player node. You'll see the property now appears in the script variables section of the inspector. Remember, if you change the value here, it will override the value written in the script. Right. So there it is, speed 400. And oh, because this one does not have export in front of it, it doesn't appear. So starting to make a little sense. Okay, inspector, yep, that's what it looks like. The ready function is called when a node enters the scene tree, which is a good time to find the size of the game window. Ah, gotcha. So we're setting the mobile screen, mobile resolution, phone screen size. So in our ready function, we'll call that screen size variable and set it to get viewport rect size. Okay, let's get rid of pass. And let's type in that screen size is equal to get viewport rect dot size. It is hard to see around this microphone, but all right, where was I? Now we can use the process function to define what the player will do. Process is called every frame. Okay, so like an every tick in construct. So we'll use it to update elements of our game, which we expect will change often. For the player, we need to do the following: check for input, move in a given direction, play the appropriate animation. First, we need to check for input. Is the player pressing a key? For this game, we have 4 direction inputs to check. Input actions are defined in the project setting under Input Map. Okay. I know what they're talking about. Here you can define custom events and assign different keys, mouse events, or other inputs to them. For this game, we will map the arrow keys to the 4 directions. Click on Project, Project Settings, Input Map, tab to the top. Oh, tab at the top. Moving right, add a button, and add the Move Right action. Oh, that's a lot. Okay. Project Settings. What are we looking for? Map? Something. Input map. Input map. Got it. The tab at the top. I read that part. Action. We're looking for move right. Move right. Oh no, I'm making a new action. This is our own custom action, and it's called move right. I gotcha. Okay, there it is at the bottom, move right. And then add the move right action. So we hit this little plus guy. Nope. That's not what it's talking about at all. It just said add move right. I need to pay better attention to the instructions. We need to assign a key to this action. Click the plus icon. Oh, okay. To the right. Then click the key option. Press the right arrow key on your keyboard. Okay. Click the key option. Key. Okay. I pressed right. Fantastic. Repeat these steps and add 3 more mappings. Move left, move up, move down. Okie doke. Let's try it out. I'm gonna go move _ left. Add. Plus key. Left arrow. Move _ up. Add. Plus key. Up. And move down. Add. Get our key. And down arrow. Okay. And I bet we're done. We are. Click close. We only mapped key to each input action. You can map multiple keys. Gotcha. We won't get into that just yet. You can detect whether a key is pressed using input is action pressed. Input dot is action pressed. which returns true if it's pressed and false if it's not. Okay, so I'm going to type all this out. I feel like that's the way to get my muscle memory going for their syntax. I am not a copy and paster of other people's code. I just don't feel like I learned that way. So we're going to do a process function, and we're going to call it delta. And then we'll get a variable for velocity. Then we'll set up our keystroke detection. And then we'll move on to the rest of that code here in a minute. Okay, let's close. And this is a process, so come up here, func space process delta. Oh, and it puts the colon after it too. That's cool. Let's establish a variable called velocity, and that is equal to a vector 2. Dot 0. All right. And now we start on that if statement. So if, and we want the input dot is action pressed. Not just pressed, but pressed. And we're going to go to move right. And we'll put a colon, indent underneath it, and say velocity. Oh, you know what I did? I wonder if it matters. I think that ready function is supposed to go above it because it's the first thing that happens in the script, I do believe. We'll change that in a second. Okay. Velocity dot x is equal to plus equal 1. So plus equal 1. And I said equal first. Okay. I am going to do that. I know I just said I don't copy and paste code, but I typed this out myself, so I'm going to use it. Oops. There we go. Let's do... Oh, no, I already copied it. So now we can change move right to move left, and this should be minus equals 1. Because it's going to the left of the screen. I have an extra light lit up on my keyboard. I don't know what that's about. Okay. Let's do another one. This will be... and this will be y, and I believe that going up is minus equals. It is velocity dot y minus equals. Fantastic. And we'll do another one. And this is going to be move down, and our velocity is on the y-axis, and it is going down, so that's plus equals 1. All right. Okay. Excuse me. All right. Next, we're going to check if the velocity dot length is greater than 0. If so, velocity equals velocity normalized multiplied by speed. Did they explain that up here? No, they did not. Okay. Else animated sprite stop. Okay, so if this says if we're moving, we're going to play animated sprite. Else, if we're not moving, it will stop. Cool. All right. Let's go if velocity.length is greater than 0. Velocity equals velocity dot normalized. You're not going to give it to me? I thought it would predict. It didn't. That's cool. It still works. Multiplied by our speed variable. And that means we want to play the animated sprite, and we get the animated sprite node, this animated sprite node up here, by using the $sign. There we go. Animated sprite. And once we have it, we'll say dot play. And looks like we're going to be doing a little more work on that. So we'll leave it like that at the moment. Else. And then we will animated sprite dot stop. All right. Got it done. Okay, we start by setting the velocity to 0. By default, the player should not be moving. Then we check each input and add or subtract from velocity to obtain a total direction. For example, if you hold right and down at the same time, the resulting velocity vector will be 1 and 1. In this case, since we're adding a horizontal and vertical movement, the player would move faster diagonally than if it just moved horizontally. That makes sense. That's why we use normalized. Okay. So saying velocity normalized makes sure that if we move at a diagonal, the speed is the same. That makes sense. Very cool. We also check whether the player is moving, so we can call play or stop on the animated sprite. $sign is a shorthand for get node. I actually knew that one. Have fun. Gotta go. Hey, thanks for stopping by. We'll see you next time. Have a good night, man. Or whatever time it is where you are. It's nighttime for me. Okay. In GDscript, $sign returns the node at the relative path from the current node, or returns null if the node is not found. Since animated sprite is a child of the current node, we can use that. Okay, I gotcha. We can use the shorthand. Excellent. The $sign is new. It's helpful though, as far what I can tell here in GDscript. So that's kind of cool. Okay, let's continue on. Now that we have a movement direction, we can update the player's position. We can also use clamp to prevent it from leaving the screen. Clamping a value means restricting it to a given range. Oh, cool. That's interesting. Add the following to the bottom of the process function. Make sure it's not indented under the else. Oh, gotcha. Okay, still in the process function. What do I do with my instructions? There we go. Okay, we're going to add position plus equals velocity times delta. Position.x clamp from 0 to screen size x and y to, or 0 to screen size y. Okay, that makes sense to me so far. So position plus equals velocity multiplied by delta and then position dot x. Okay. Equals clamp. Oops. Then we want to get position x. Position dot x, comma. Okay, that's determining which direction we're clamping. So position x, comma, and then from 0, comma, to screen size dot x. And I'm going to copy that. And position y is equal to clamp dot position y, screen size dot y. And while I'm here, I'm gonna save because I haven't been remembering to do that. Delta parameter in the process function refers to frame length, the amount of time that previous frame took to complete. So delta time. It's just spelled out delta in Godot. Cool. Click play scene and confirm that you can move the player around in all directions. Okie dokie. Is that play scene? Are you play scene? Play the project. Play scene. Oh, there I am. Hey. Looky there. And it animates and stops animating. Very cool. And our diagonals work. And I am clamped to inside the screen. I guess it goes by your origin point in the middle and not the collision capsule. Okay, good to know. Okay, choosing animations. Ugh. Now that the player can move, we need to change which animation the animated sprite is playing based on its direction. We have the walk animation, which shows the player walking to the right. This animation should be flipped horizontally using flip H. For left movement, we also have the up animation, which should be flipped vertically for downward. At the end of process function, so still in the process function, right? Yeah, because we're updating every frame. Okie doke. let's get that working. Can I not? Nah, I won't worry about it right now. Let's add if velocity dot x is not equal, the exclamation point means not equal to 0. So if we're moving, let's grab that node, animated sprite dot animation equals walk. Oh yeah, that's the frame. Okay, the animation. And then let's grab that node again, animated sprite dot flip horizontal, and that will equal false. Okay. Is not equal to 0. Okie doke. I'll trust them. Let's grab that node again. And the animated sprite dot flip horizontal. No, vertical. Vertical. Oh, I did that backwards from what they have. So I'll do vertical there, horizontal here. And that will equal, the horizontal will equal to, okay, I gotcha. That makes sense now. So if the velocity is not 0, that means we're walking and we're telling it to flip it, not vertical because we're walking, that's our left and right movement. So horizontally, we will equals velocity dot x is less than 0. I have no idea. Hopefully this is explained a little more. Velocity dot y. This is if velocity y is not equal to 0. Oh, nope. I did that wrong. Not that, and it's an elif. Else if. So that means we're going elif, not else. Elif. There we go. Okay. And let's grab those nodes again. Let's go animated sprite. Dot animation is equal to up. And then get that node again, go to animated sprite dot flip. What did I do? Flip vertical. Right? Yes. Equals velocity dot y is greater than 0. Okay. All right. I think I struggled through that one. That's all right. We're going to save. And let's see what we just did. Boolean assignments, the code above. Okay. Play the scene again and check that the animations are correct for each direction. Cool. All right. I don't know about the going diagonal part, but maybe they take care of that later on. When you're sure movement is working correctly, add this line to the ready function. Also, player will be hidden when the game starts, or so the player will be hidden when the game starts. Okay. Let's go back up to ready. And hide. That seems easy enough. We want player to detect. All right. We want the player object to detect when it is hit by an enemy, but we haven't made any enemies yet. That's okay, because we're going to use Godot's signal functionality to make it work. Add the following to the top of the script after extends area 2D. Nope. Stop that. Signal. Hit. This defines a custom signal called hit that will have our player emit when it collides with an enemy. We will use area 2D to detect the collision. Select the player node and click Node tab next to the Inspector tab. Okay. Okay. In list of signals that the player can emit. Okay. I know what they're talking about. So player, right? Player. And then go to nodes. Okay. Node tab and see a list of signals that it can emit. Fantastic. Notice our custom hit signal is there as well. It is. I see hide. Oh, hit. It's at the very top. I was staring right at it. This signal will be emitted when a body contacts the player. Click Connect and connect a signal window appears. We don't need to change any of the settings. Connect again. Automatically create a function in your player's script. Okay. Our enemies are going to be rigid body nodes. We want body entered. Body entered. Entered area. Entered body. Body entered node. Okay. Gotcha. Signal will be emitted. Huh. Okay, connect. And it said everything is good to go. Just click connect again. And there's us a function on player body entered body. Okay. Okay. Note the green icon indicating a signal right there. And the code to the function. Oh, add this code to the function. So we're going to hide after being hit. Emit signal hit. Oh. Collision shape 2D. Set deferred. Disabled. True. Wow. Okay. So let's hide it. Hide. and then emit signal, hit. Oh, it's got to be in quotes. HIT. Okay. I don't know why that looks weird. All right. Okay, after we emit the signal, we hide, emit the signal, and then we grab the node of collision shape 2D dot, and we set it to deferred. Set deferred. Disabled. Disabled, comma, true. Oh, I said dot. I meant comma. All right. There we go. I'm going to save that. There we go. Each time an enemy hits the player, the signal is going to be emitted, and then we disable the player's collision so that we don't trigger the hit signal more than once. Okay, makes sense. It can cause an error if we don't disable it. Oh, if we do disable it in the middle of processing. We use set deferred to tell Godot to wait to disable the shape until it's safe to do so. Ah. Okay, set deferred. Disabled. And then you set that to true. Makes sense? Kinda. The last piece is to add a function we can call to reset the player when starting a new game. So a function start POS position. Position equals POS show. With the player working, will work on the enemy in the next lesson. Okay, we're resetting the player to start a new game. Okay. I trust you. Let's do a func start and POS. It doesn't really explain what that is. Is POS built in, or did we just name it that? Position equals POS. Yeah. So what is that? Does that mean that's one of my custom ones? I don't know. And then we'll do a show. And we'll grab that node of collision shape 2D. And dot disabled. When it's disabled. Oh no. We're setting its disabled property to false. Ah, so that. Gotcha. So that allows us to be able to play the character again, because this function disables our player, and this one starts us back up. Why am I throwing errors here? Because I don't know how to spell, that's why. There we go. Okay, I'm gonna save that. And I don't think there's anything to test. I think it's, yeah, see, our player's not there. So, we hit it up here. No, not there. Hide, right here, in the ready function. Okay. All right. Let's move on to the next one. And actually, I'm going to take a very quick break, I will be back in just like a couple minutes at the most. In just a minute, I will. Why can I not see? All right. All right. Okay, I'm going to take a quick break. I'll be right back. All right, we got us a visitor. This is my little baby. Her name is Princess. She's made a few appearances on this channel. And she loves being an only dog. Because we lost our other two just a few months ago. And we're about to go adopt another one. Or maybe a couple. Sure do love our dogs around here. All right, she's going to hang out in my lap while we continue. Okay, new page. Oh, we got a few more sections to go, don't we? Okay. Let's get moving. Now it's time to make the enemies our player will have to dodge. Their behavior will not be very complex. They spawn randomly at the edges of the screen, choose a random direction, and move in a straight line. We'll create a mob scene, that's funny, which we can then instance to create any number of independent mobs in the game. All right. Click Scene, New Scene, and add the following nodes. Okay. Okay. I think I know what I'm doing. Maybe. Rigid body, animated sprite, collision shape, and visibility notifier. Wowzers. All right. So, scene, new scene. And this will be a rigid body 2D. My dog. She is quite the distraction. Okay. Uh-oh. No. I put it inside the player. Let's... delete node rigid body 2D. Yes. Okay. Scene. Oh, add. Okay. Open script. Node 1. Oh, scene. All right. Nothing to see here. Don't expect any Godot scenes. Or Godot tutorials anytime soon. Man, I have no idea what I'm doing. Okay. Let's add a rigid body. And we'll name it Mob. There we go, Mob, with a capital. And then I will select it. We'll add a child node of animated sprite. I'll add another one of collision shape 2D. And a third one, visibility notifier. Yes, notifier 2D. Uh-oh. There we go. I had a child of the collision shape. That's not correct. All right. Okay, sorry. Just checking on some things over here. Where was I? Okay, this is unsaved. Let's save that. Oh. Wait, what? My player script is unsaved. I've saved it several times. Have I not? Have I not been saving it? Okay. Project. Save. Let's go to player. Expand that. Let's try this again. Oh. Wait a minute. What happened? Okay. Save that one. What is this? What happened here? Why do I have... don't save. Because I don't need that. Oh, yeah, I do. I just... Oh. Why did it copy the... That didn't make any sense. Let's try this again. New scene. Rigid body. And we'll call it mob. Okay. Maybe that's what it is. Mob. Let's save it. I just don't understand that. So, how do I go back to the layout? How do I do that? I have no idea. How do I get rid of the script and go back? Edit the document. Oh, it's up here. Oh. I also just noticed that I never changed back to live, so you'll have absolutely no idea what I'm talking about. Okay. Let's try that. Okay. Mob has nothing in it. It looks good. Okay. I need to finish this up. I deleted it for no reason. That's okay. We will put in an animated sprite. We will add another child of a collision shape 2D and one more of visibility notifier 2D. Excellent. All right. I'll save that. We are good to go. Let's move on. Okay, don't forget to set children so they can't be selected like you did in the player scene. Okay. Select the mob and group selected nodes. Make sure. Okay. I think that's correct. I think that's what we did. We'll find out. In the rigid body 2D properties, set gravity scale to 0 so the mob will not fall downward. Oh, because it has a rigid body node to it. I gotcha. In addition, under the collision object 2D section, click the mask property and uncheck the first box. This will ensure the mobs do not collide with each other. Oh, okay. Rigid. My rigid body, 2D. Gravity scale to 0. Collision object 2D down here. Mask. What now? Collision. Oh, there's mask. Gotcha. Click the mask property and uncheck the first box. Okay, cool. Set up the animated sprite like you did for the player. This time we have 3 animations: fly, swim, walk. There are 2 images for each animation in the art folder. Adjust the speed frames per second to 3 for all animations. Okay, let's get those inserted then. What did we do? Animation player node. Oh, animated sprite. There we go. How did we do that? New sprite frames. Okay, there we go. And we have, let's see, flying. And we'll do a new one. Call it swimming. And another one. Call it walking. Flying, walking. And then, oops, let's do 3 for each one. Okay. Set the playing property in the inspector to on. Set the player. We'll select one of the animations randomly so that the mobs have some variety. Okay. What did it say in the inspector? Select playing. Oh, there we go. Maybe? Huh. Set playing property in the inspector. There it is. I was looking everywhere except for right there. We'll select one of the animations. Okay. Like the player images, these mob images need to be scaled down. Set the animated sprite's scale property to 0.75. Okay, scale. Which one? Oh. Animated sprites. Scale. Under transform, right? Yeah. 0.75. 0.75. Oh, I didn't move anything in there, so let's do flying. All right. Let's do swimming. And let's do walking. Okay. Animation flying, swimming, and walking. I like the swimming one. Okay. Back at it. That is set at 0.75. As in the player scene, add a capsule shape 2D for the collision. align the shape with the image, you'll need to set the rotation degrees property to 90. Okay. So let's add a capsule in the... how did we do that? Capsule shape 2D. Oh, it's right there. Empty, new capsule shape 2D. Then we can zoom in. Oh, okay, I gotcha. It needs to rotate. Rotation 90. There we go. There we go. Looks good to me. And save the scene. Saved. Okay. Monster is done. What are you doing, huh? This dog sure is keeping my lap warm. And it's not necessarily cold in here. Add a script to the mob. Like this. Extends. Okay. Well, we know how to do that, right? Plus. Rigid body 2D. Looks good. Cool. And get rid of some of this. Okay. Let's look at the rest of the script in Ready. We play the animation and randomly choose one of 3 animation types. Okay. First, we get a list of animation names from the animated sprites frames property. Okay. This returns an array containing all 3 animation names: walk, swim, fly. We need to pick a random number between 0 and 2. Select one of the names from the list. Randy is random. Selects a random integer between 0 and n1. Okay. I don't fully understand yet, but we shall find out. Okay, in our ready function, we'll grab the node of animated sprite dot playing equal to true, and we'll create a variable inside the function called mob underscore types, and that will equal that node again, animated sprite dot frames dot get animation names. Okay, I kind of follow it now. Give myself a little room here. Then we will, a new line, grab that animated sprite node again, dot animation is equal to mob underscore types, and then we're gonna do an array. Yeah, that music just weirds me out sometimes. Okay, in the array, we're gonna run that random keyword RNDI Let's just finish this and see if it counts it. I don't know. Kind of weird. Mob types dot size. Okay. What did I do wrong here? My array right here. Oh, what's that about? Okay. Oh, that fixed it. Okay, cool. Okay. So what we just did was we got a list of the animation names from the animated sprites frames property right there. This returns an array, which is all the names. And then we access that array from 0 to 2. Oh, because we already got the size of the array, which is 3. So 0, 1, and 2. And then we did a random, select a random integer. Okay. Looks good to me. Moving on. The last piece is to make the mobs delete themselves when they leave the screen. Connect the screen exited signal of the visibility notifier 2D node and add this code. Okay, so visibility notifier, go to nodes, screen exited. Yes. Mob. Yes. Connect. Yes. Queue free. Okay, queue free must get rid of everything. Queue free. Okay, with players and enemies ready, in the next part we'll bring them together in a new scene. We'll make enemies spawn randomly and tune our project into a playable game. Okay. Cool. Clean this up a little. That was easy enough. That was a lot easier than the player. Or there's just a lot less. The player script has some stuff going on. Mobs seem like they're a bit easier to deal with. And let's go to the next page. Okay, create a new scene and add a node named main. The reason we are using a node instead of node 2D is because this node will be the container for handling game logic. It does not require a 2D functionality for itself. Okay. So, scene, new scene, and what? Add a node. A node. Does it matter? Node? Ah, okay. Seems easy enough. Call it main. And then we can save it into our folder. All right, main. So now, click the instance button and select your saved player file. Add the following nodes as children of main and name them as shown. Values are in seconds. Oh, okay. Okay, so let's get the, and we want the, which one? Player. Okay, open that up. Okay, so now all of that is within our main node. And I can just switch them with these tabs up here. Okay. This is going to take a lot of practice. All right, that's cool. That's what I like doing. Okay. Add the following nodes as children of main. Okay, a timer node as children of main. Let's say timer. And what did I just do with my instructions? There we go. Timer named mob timer, score timer, and start timer. Okay. Mob timer. Let's do another one. Call it score timer and move that into main. Gotta remember to select the right node before you do it. And then this one is the start timer. Start timer. Okay. And we need a position 2D node as a child. So position 2D. Start position is what we'll name it. Start position. Okay. Let's go to the inspector and we get wait time. So for mob timer, wait time is 0.5. Score timer 1. Start timer 2. And okay, those are timers. Start position is not a timer. That's why I couldn't find the time. All right. In addition, set one shot property of the start timer to on. Set the position of start position node to 240 by 450. Okay. So that was start timer. Set the one shot to on. And position of the start position. Okay. Transform position was 240 by 450, 240 and 450. Okay. Spawning the mobs. The main node will be spawning new mobs, and we want them to appear at a random location on the edge of the screen. Add a Path 2D node named MobPath as a child of main. When you select Path 2D, you will see some new buttons at the top of the editor. All right. Go to main, new one, Path 2D. And you said I was going to see new buttons. I don't see any new buttons. Oh, I need to name it Mob Path at the top of the editor. All right. Mob Path. Interesting. Okay, I'm going to save that. And let's see. Oh, okay. This editor, right? Yeah, right there. There they are. That's what they're talking about. I'm going to figure this out eventually. Select the middle one, add point, and draw the path, clicking to add points at corners shown. To have the points snap to the grid, make sure to use grid snap and use snap are both selected. These options can be found at the left of the lock button appearing as a magnet next to blah, 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 blah. Okay. So I just need to click the 4 corners. Is that what they're telling me? So let's turn on grid snap, and is that smart snap? Maybe. Okay. What does this say now? Select the middle one to add point and draw the path by clicking to add the points at the corners shown. At the corners? I feel like I'm missing something here. Well, let's see what we got here. I just don't know where. Oh, there's our layout. Okay, I'm gonna add one there. What's that one? Oh, close curve. Okay, and then it snaps into place. Oh. Did it already do it? No. Okay. Is that how you do it? Appearing, okay. Draw the path in clockwise order or mob's spawning point outwards instead of inwards. Okay, I did that. After placing point 4, click the close curve button and it will be, okay, 1, 2, 3, 4. Oh. That's what it did. Okay, I did that wrong. There we go. Okay, that one's still selected, so we can close it. Nice. Okay. Gotcha. And now the path is defined. Add a path follow 2D node as a child of mob path. Name it mob spawn location. This node will automatically rotate and follow the path as it moves, so we can use it to select a random position and direction along the path. All right. Mob path, child, and we want a path follow 2D. Path follow 2D. And we'll name it mob spawn location. So mob spawn location. Okay, main script. What you doing, dog? Hmm? All right. Got a dog in my lap. Let's see here. Add a script to main. Done. Move this stuff. Oh, I should have left pass. And we'll do that way. Okay, extends node. That's correct. Why do I keep losing my... There we go. Okay, extends node, and then we're going to export a variable mob scene and create another variable called score. Okay. I have not seen the packed scene version yet, so let's go set an export variable. Do I type that in? Packed scene. Packed scene. There it is. All right. That's a new one to me. Mob underscore scene. Mob scene. And then we'll create another variable. You're making this very hard, dog. I'm trying not to smack you in the head. I'm trying not to. Okay, and a score variable as well. Okay, we also need to add a call to randomize so that the random number generator generates different random numbers each time the game is run. We'll do that with the ready function, and we'll just call that randomize. Randomize. There he is. Okay. Click the main node and you'll see mob scene property in the inspector under script. That's because we determined it with export. So main, and there's our mob scene variable. All right. You can assign this property values in two ways. Drag the mob file from file system, which is going to be that one. Oh, God, I did it again. Okay. File system, drop it in the mob scene property. In the mob scene property. Oh, in the empty. Okay. Click on the down arrow next to empty and choose load and select mob. Let's do that way. Let's say load and get to mob scene. Cool. Hadn't done it that way yet. What? I'm sorry. I'm sorry. I disturbed your nap. I know. Okay. Next, select the player node in the scene dock and access the node dock on the sidebar. Make sure to have the signals tab selected in the node dock. Okay. Player node in the what? In the scene dock. Is that up here? I guess. To access the node dock on the sidebar. Is that? What is that? Is it this one? Access the node dock on the sidebar. Make sure to have the signals tab selected in the node dock. Okay. I guess. You should see a list of signals for the player node. Find and double-click the hit signal in the list. Okay. I should have just read through that instead of trying to... okay. It's a good tutorial. I find ways to be frustrated all on my own. Not the fault of the author. Okay, list the double-click hit signal in the list, and we will connect it to. I don't know. Okay. Once I do that, I need a game over, right? Player connecting from signal hit. Alright, click connect. This will open the signal dialog. We want to make a new function named game over, which will handle what needs to happen when the game ends. Type over the receiver method box and click connect. Okay. So we're going to call this game over. Yes. So game underscore over connect. And there we go. We now have a new function. Thank you, Godot. Go ahead and save that. Okay. Struggling a little bit here. Add the following code to the new function, as well as new game function that will set everything up for a new game. Okay, I got you. So we're going to do a score timer dot stop and a mob timer dot stop. That's game over. Okay, we want to stop our timers. Gotcha. So let's get that node, which is the score. Oh, you're not going to give it to me again? Okay. I like it when it predicts what I'm going to say. Dot stop. And then we'll close that off and do the same for the mob timer. Mob timer. Yeah, okay. Dot stop. Close it off. All right, and then we're going to create a new function. We will call this one new underscore game. And okay. Scroll down so I can see what I'm doing. New game. Okay, in this function, we're going to set the score to 0. Player.start, and we'll call it starting position, and then we'll start the start timer. Okay? Sounds simple enough. As long as I have it spelled out for me right in front of my face. Score equals 0. And let's grab the player. It is capitalized. The player node. I wonder why it's not seeing my other nodes in game. Huh. Just wondering if I did something wrong. Player.start. And that is, we're going to get the start position node. Start position dot position. Boy, it's not. It does not want to do anything for me. Okay. Let's see. Player.start, and then we grab the start position node. Position that sets it, and then we want to grab the start timer node and tell it to start. So grab start timer dot start. Okay. Uh-oh. Score is not declared in the scope. That's because this is supposed to be another signal, isn't it? Dang it. I did not get that from what they said. This will open connection. We want to make a new function which will handle when it needs to happen when a game ends. Add the following code to the new function as well as a new game function that will set everything up for a new game. Now connect the timeout signal. I don't know. I don't think so, right? Let me make sure that I'm in the right spot here. Select the player node. Okay, so we're in the player node. All right. It's not in the well, it's inherited into the main node. So starting to struggle a little more. Okay, now is score? Did we have a score? I don't think we had a score, did we? Oh, it is from the main. Okay. So, is this supposed to be? It is supposed to be in the main. Right? Isn't that what it said? I'm lost now. I knew this was going to happen. Okay, next, select the player node in the scene dock and access the node dock on the sidebar. Make sure you have the signals tab selected in the node dock. You should see a list of signals for the player node. Find and double-click hit in the list or right-click and say connect. This will open the signal connection dialog. Hey, Rafael from Brazil? Man, that's awesome. How's it going? Welcome in. Thanks for stopping by. Oh, excuse me. I'm just trying to figure out how Godot works, and it's been a while, and I don't remember much of anything. So this is it's been a little challenging since I got started tonight. But that's okay. I'm determined to learn more about this game engine. Okay. Let's see, what am I doing? Okay, I did that. Make a new function named game over. Game ends, type game over in the receiver method. Click the main node and you will see the main property under script variables. Okay, I think I did that though, right? Main. I'm going to save that. Did I? What? I'm just lost. That's all there is to it. In the inspector, script variables. Okay. That's right, mob scene. And then we dragged that in. That's right. Okay, we did all that. Select the player. So, I mean, I guess we're in the player script, because it doesn't say to put this in the main script. And I feel like this score variable should be seen. And it can't be seen unless it's in the main. Man, goodness. List in the scene dock. Player, node, hit. Did I... No? Connecting from... And because that's connected right there. I feel like... Oh, could look at the completed version of this to see where it goes. On mob timer, timeout. Yeah, see, this does not say to go back to the main the main node. Okay. I'm just going to continue on and we can just copy and paste. Maybe. Okay. New game function, blah, blah, blah. We did that. Connect the timeout signal of each timer nodes, start timer, score timer, and mob timer to the main script. Okay. I swear I just read over that part. Okay. I am going to hang on just 1 second. Oh. How about a drink of water? The dog does not like getting her eyes cleaned out. Poor thing. Okay, so how do we do this? Connect timeout signal of each of the timer's nodes. Okay, so let's go back over to main. Mob timer, timeout. Connect it to what? To the main script. I have no idea what that means. Okay, now connect the timeout signal, each timer nodes, and to the main script. Okay, connect to script main. Yes. Yes. On so that was done incorrectly. On score timer timeout. So go to score timer and let's do it that way. Connect on score timer timeout. God, that just doesn't. I just don't get that from this paragraph. I don't know. I don't know. All right. So let's get rid of this. I'm gonna come up here like that. Function on score timer timeout. Then we'll grab that score and plus equals. Whoops. Let's do it that way. Plus equals. This is hard to do with a dog in your lap. All right. And so do I do it again? Because I do it there, do I Do I connect it again? It seems like I do, huh? Alright, I'm gonna do it. I'm gonna do it. Let's go score timer. Timeout. Main. Connect. Oh, nope. That's not it. Okay, fair enough. I will copy that. Put it right there. Come up here, and what do we want to do? We want to, we got to grab our mob timer and our score timer. Oh my goodness. Okay. I did that terribly wrong. Goodness. Okay. I'm just a mess tonight. Let's get rid of this. Let's get rid of that. Let's get the correct timer, which is start timer to main on start timer timeout. And then now we'll get that score and do a plus equals 1. So it will go in increments of 1. Okay. Now we can copy this. Boy, I messed things up, huh? On start timer timeout. Okay, we're just, I wonder why we can't put it in the same function. I mean, because they're both the same exact function. Already exists in this class at line 10. Oh, it was the score. That. Oh, if I could just edit this out. Can I just drag that over there? No? Nope, can't do none of that, huh? All right. Gonna do score timer. There we go. Okay. Sure would like to edit that out. It's pretty embarrassing. Okay. Score plus equals 1. I think we'd have that down pretty good at this point. Start timer, timeout. Now we can go grab our mob timer and tell it to start, and grab our score timer and tell it to start also. Okay. All right. That should not have taken that long. That is a little frustrating. Okay, I got me some messages. Okay. Sorry about that. Just a quick interruption. Okay. In the mob timer timeout, we'll create a mob instance, pick a random starting location along path 2D, and set the mob in motion to follow the path. The path. Okay. in motion. Path follow to the node will automatically rotate as it follows the path, so we'll use that to select the mob's direction as well as its position. When we spawn a mob, we'll pick a random value between 150 and 250 for how fast each mob will move. It will be boring if they're all moving at the same speed. Note that a new instance must be added to the scene using add child. Okay. Okay, looks like there's quite a bit of stuff going on here. So we'll put the mob timer timeout in its own function. Do I need to is that a signal? Do I need to signal that like I did those? I don't know. I'm gonna say no because it didn't say that. So there you go. Okay. We'll create a variable and our mob spawn location. Okay, I think this is just gonna have to be something that makes sense to me after I kind of get it all put in here. All right. Let's go with that new function. And this will be on mob. Oh man, I can't see anything. This dog in my lap is making everything very difficult. Okay, where was I? Mob timer timeout. Mob timer underscore timeout. Seems like a very long name for a function. That's okay. Let's create the variable of mob and set it to mob scene dot instance. And they're going to make me type the whole thing out. It's very rude of them. Okay. We're going to need some more variables. What do you want, dog? Okay, I'm going to have to put you down, okay? You're kind of making things difficult. Don't look at me like that. Okay, you can stay. And that is how easy that works for her. Mob underscore spawn location. Okay. Spawn location. Oh man. Okay, dog. I changed my mind. You are going in the floor. Equals get node. Okay. Get node. And we gotta get a path. So mob path spawn location. Oh, at least it gave me that one. That was good. Mob spawn location dot offset. Mob spawn location dot offset equals the random, which is Randy. I wonder why it's like that. I don't know. I've quit questioning things for Godot. I just don't quite understand them. Mob spawn. Okay, let's continue with another variable. And that is going to be direction. And that is going to equal the mob spawn location. And this is where we rotate it. So dot rotate Oh, nope. Rotation. And then we will add pi divided by 2. And there's some math that I have yet to wrap my head around. Okay, now we need to get the mob's position. Mob.position is equal to mob spawn. Mob spawn location dot position. Okay, that kind of makes sense. All right. I don't know if that... I hope I did that right. I don't know. We'll find out, won't we? Okay. Where am I? Add some randomness to the direction. So we're going to go direction plus equals rand range. Rand range. That's a new one for today. Negative pi divided by 4, comma, pi divided by 4. And then mob.rotation. Mob dot rotate. Really? Come on. Mob.rotation equals direction, which we just clarified right there. Okay, one more variable here. Man, it's a lot of variables in a function, huh? Velocity equals, and that's going to be a vector2 with a rand range of 150.0, because that is apparently a float, and 250.0. And then we'll comma and 0.0. It's hard to see over there. Okay. Mob dot linear I like the autocomplete. Linear velocity. Got it. Linear velocity equals velocity dot rotated direction. All right. And then we will add child. Whew. That was quite a bit. Oh, what child are we adding? The mob child. Okay. Whew. God, that was a lot. Okay, why pi? In functions requiring angles, Godot uses radians and not degrees. Pi represents a half turn in radians. Did not know that. There's also TAU, which is equal to 2 times pi. If you're more comfortable working with degrees, you'll need to use that one and that one functions to convert between the two. Okay, interesting. I'll have to look into that another time. Let's test the scene to make everything is working. Add this new game call to ready. Okay. Func ready. We have that randomize. So now we just need to add new game. Why did that not? Oops. Isn't declared in the current class. Huh. Why not? New game. Where did I put that? Oh, it was over here. So, do both of those need to be in there? Let's also assign main as our main scene, the one that runs automatically when the game launches. How do you do that? Let's also assign, new game. So I guess it just needs to be over there, huh? I'm doing it. I'm gonna do it. Let's put it before our timer timeouts. And now, let's see if new game comes up. It does. Okay. Well, then that means this one also has to go over there. So let's put that in. We'll put it in right there. All right. And let's check this one. Score equals 0. Uh-oh. Somebody's here. Are you gonna go get her? Okay. Had to let the dog into the floor. Her mama is home. Okay, let's also assign main as our main scene. How do you do that? How do you do that? Scene. I wonder how you do that. It doesn't say how to do that. I don't understand. Oh, okay. I gotcha. You press the play button and select. I could have just said select current, but I want to make sure that we're on main. And there we go. Okay. And there we go. Oh, and I died. How do we... F5? No? F6? No? Okay. Let's try it again. Oh, man. So that's a little on the difficult side, huh? Oh, but it works. Man, that is pretty difficult. Okay. Well, very cool. You should be able to move the player around, see mobs spawning, and see other player disappear when hit by a mob. Yes. When you're sure everything is working, remove the call to new game from ready. What's our game? What? Oh, really? Well, why? Okay. If you say so, let's see if that still works. Yeah, it doesn't. Why? Why did I do that? Huh. I mean, what's in here? Yeah, that's dang it. I don't think that needs to be removed. If you had already set another scene as main scene, you can right click in the file system. Oh, really? Okay. So you can just set as main scene. Fair enough. But still, it made me delete something that I think we need because it doesn't work without it. From new game. Maybe when we put the background, score label, message start button, connecting HUD to main, removing old creeps. I don't know. Okay. We'll leave it out for now since that's what it said. And I'm going to make sure everything, save all scenes. All right. Oh, what is that? That is, hey, I went 2.5 hours. I think I'm going to go ahead and stop here and then hopefully can get on tomorrow. And I'll let everybody know ahead of time, a lot earlier than I did today, and we'll finish this up. And then I'll have perhaps I can have a new project to start on once we finish that. So, and this was a lot of fun. Thank you, everybody that. Oh, okay, sorry, had a notification. Thank you, everybody who stopped by and said hi and just checked it out. If you aren't subscribed to the channel, you probably should be. I think so. And let's go there. So yeah, a lot of fun. I'm gonna do this a lot more often, and I learned a lot about how YouTube handles streaming tonight. I want to get that down, and then eventually I'll be able to set up both, well, not both, but I want YouTube, Twitch, probably TikTok, Facebook, and anything else that I can put this stream up on and just do it all at the same time. So that's my plan. And I haven't stopped doing things with Construct 3. In fact, maybe in tomorrow's stream we'll take a look at some projects I've been working on before they're finished. That could be fun. So yeah. All right. Thank you for hanging out with me. This was fun. We'll do it again. And I will see you next time. Take care.